All right, tonight we focused on volume, and by way of quick review, last year you dealt with a formula for volume that was length times width times height, and that volume was highly successful when you were dealing with cubes and when you were dealing with rectangular prisms. Now that we're no longer dealing with rectangular prisms and cubes alone, but rather we've introduced a number of other shapes that are going to make the formula that we need to use to identify volume slightly different. We've transitioned into this formula of volume equals base, which is whatever the base of our particular object is, times its height, which we discussed when looking at a two-dimensional shape such as a triangle, and we turn that triangle into a prism. The height is that distance that that triangle extends out from the original base. We also looked at pyramids and cones today, and remember that we said that pyramids and cones have a slight variation of that formula. It's V equals 1/3 big base times the height. And we used a couple of visual aids in class so that you could see that the volume of a cone, when given the same dimensions of a particular cube, will take up 1/3 of the amount of space. And that's why we use this formula, 1/3 BH. So let's look now at problem 1. A glass paperweight is in the shape of a triangular pyramid as shown. What is the volume of this weight to the nearest tenth? Well, since we're dealing with a pyramid, I know I'm going to use this second formula down here, V equals 1/3 BH. And now I need to figure out a couple of things. First, my base of this shape. Well, we called it not sure why we called it a triangular pyramid. We have a square for a base. So we have a square pyramid. And so in order for me to find the area of a square pyramid, I need to first find the area of the base, which is, in fact, square. So that big B, the area down here for my base, is going to be 1.5 times 1.5. And this is a good spot for you to use a calculator if you wish. You're welcome to multiply these out by hand, but at least I have shown enough work that you know what I'm doing, and when I'm looking at your paper, I'll be able to tell what you're doing. So now my big B is equal to 2.25. So we will come back to our original formula. V equals 1/3 times 2.25 times my given height is 2 inches. So I'm going to go ahead and multiply the 2.25 times 2, and that will give me 4.5 over 3 is equal to my V. And so when I divide 4.5 by 3, I find that my volume is 1.5 inches cubed. Let's look at another one. I'm going to come down here to this compound shape number 4. Marcia has 450 centimeters cubed of putty to pour into the following container. Will all of this putty fit into the container? Justify your answer. Well, in order to justify our answer, we're going to have to find what the volume of this particular container can hold. And again, I'm going to continue to use the V equals BH formula so that I can get the extra practice doing so. So starting with the square, or I guess we would call that rectangular prism since it's not really a true square, a rectangular prism. The base of this particular rectangular prism is 10 times 4. So my big B is equal to 10 times 4. So V equals now 10 times 4 is 40 times the height of my rectangular prism, so times 7. So V equals 280 centimeters cubed. Well, now let's find the volume for the triangular prism. See here I have a triangle shape. That triangle shape gets extended. So again, we're going to use the V equals big B times H. In this particular instance, my big B is going to be the area of my base, so the area of this triangle, which is 6 times 10. Again, the formula for area is 1/2 6 times 10. So my big B is 1/2 6 times 6 times 10. Half of 6 is 3. So 3 times 10 would be 30. So we look at V equals 30 times the height. Now we need to refer back to our image. The height, it extends 4 centimeters away from the original base. So V equals 30 times 4 would be 120 centimeters cubed. So the two volumes I've ended up with are V equals 280 centimeters cubed and V equals 120 centimeters cubed, and that gives me a total volume of 400 centimeters cubed. So can I pour 450 centimeters cubed of content into a container that is only able to hold 400 centimeters cubed? The obvious answer would be no. I'm going to spill over 50 centimeters cubed volume of whatever container whatever content I try to pour into this container.